Oh my gosh, I can't remember from here to there. Okay, so this particular question is saying find the gradient. What does the word gradient mean? Slope. Okay, I just want to make sure. I use it interchangeably. However, in Cambridge, they don't really use it interchangeably. They just say gradient. And I neglect, I guess, old dog, new tricks. I have a really hard time remembering the word gradient. I use slope often. But just understand, slope and gradient are the same thing. Okay? So let me write it down real quick and we'll do this problem. Find the gradient. Okay, so for this guy, oftentimes, and I'm going to say calculus, which is what you all are doing. Calculus typically is one step calculus and a whole lot of algebra. So your skills in algebra will be polished off for these particular lessons. Having said that, sometimes you want to algebra it first, then calculus, then algebra it again. This is a great scenario where your algebra skills will come into play. If I'm looking at this and I want to take its derivative, I'm going to go, listen, can I clean this up algebraically first to make it nicer to look at? Okay, and so what would you do to clean this up algebraically first? Distribute and FOIL, right? Like FOIL this puppy, distribute your X through. So I'm 100% sure that you guys are cool with distribution and foiling. So go ahead and do that at your desk. I'll do it here. We'll come back together and then we'll know if you did it right or if I did it right. Get it into this format and you look at it, the power rule is the way you will derive it. So really nice to be able to get it to where the power rule is the easiest way to go. There is another way to do it. You don't learn it at this level of math. I'm not going to teach that to you at this level. It's A level. But this is 100% the easiest way to go. So let's review yesterday. There are two ways that I can tell you to take a derivative of something. One we call y prime. Okay. The other one is dy dx. Okay, so I will interchangeably use both of those. For this, does anybody have any qualms about how to jump in to do this? I'll do it up here slowly for those that might not quite remember or haven't seen it. So the step one is you're going to take whatever that number is in front and make it go down for the right. So I'm going to bring the 2 down, and then I'm going to use the power rule. The power rule states, take your exponent, you're going to bring it to the front, you rewrite your x, and then you subtract 1 whole from your exponent. And then you do it for each individual piece of this trinomial here. So the 5 is going to come for the ride, the 2 is going to come down, you rewrite your x, and you subtract 1 whole. Is it okay? Are you guys feeling okay with it? Then the next guy, the 3 goes for the ride. Currently, x is to the first power. So a 1 comes down, we rewrite, and we subtract 1 whole. Now I would suggest you clean this up to make it more palatable to work with. 2 times 3 is 6, x squared plus 10x. And then anything to the 0 power is 1, so that whole thing would be minus 3. Thumbs up if you actually did that derivative right. Yes? Feeling okay? Are some of you like, heck no, how did I do it? Are we cool? Or is anybody wanting me to slow it down, go through it again? Are we cool? We're feeling good? Okay, so this particular question said find the gradient. The gradient means slope. What we just found is the equation that'll give us any gradient at any point on this original curve. So in this case, they told me x is 1. However, they could give me any x value. I could plug it in and find the gradient at that point. So what is the gradient at the ordered pair 1, 4? I'm going to take the 1, I'm going to plug it in, and that's going to be my gradient. Okay, so it's going to be 6 times 1 squared, 10 times 1 minus 3. So 16 minus 3 is 13. So that is the slope of this equation at the point 1, 4. How do we feel? Are we cool? Yes. From yesterday's lesson, I showed you a little more of an extension of this. I said at this point we could find the equation of a tangent line, or we could have found the equation of a normal line. Okay, so let's go ahead and practice that. That way we have that back into our brain power for now. If I asked you to find the equation of the normal, remind me, the normal is representing what type of line?
I have a question about the last one. So would you want it in that form? That would be the answer that we put down? Or the one, as the, what equations of the slope at 1, 4?
So this is the slope, yeah, that is the equation that provides any slope. The particular slope we're looking for is when x is 1. So yeah.
Mm-hmm.
Does that make sense?
Yep.
So if I'm looking to find the equation of the normal line, what's the normal line again, by the way? It's a perpendicular line, very good. Okay, so the three things I need in order to find the equation of a line are x, y, slope. So if I'm looking for the normal line of this, at this point, right, I have an x, I have a y, and what is the slope that I'm going to use? Negative 1 over 13, right? We understand if the question was find the tangent line, you would just use 13. Good to go. Find the normal line, opposite reciprocal. Are we cool? So yesterday we talked about my favorite formula, y minus 4 equals negative 1 over 13 times x minus 1. Are we okay? Now, in a perfect world, I have found the equation of the normal line. I don't have to make it pretty. I have found what I'm looking for. However, once in a great while, they will say, go ahead and make this guy in the format of standard form. Make it look like ax plus by equals c. If you quit here, you're not in that standard form. You are, yes, you found the equation of a normal line. However, it's not simplified, okay? So let's talk about how we make that simplified. I'm going to tell you, in standard form, there are no fractions. No fractions. So in this form, there is 100% a fraction, right? So first thing, I got to get rid of any fractions. So the best way to get rid of the fractions is to take the denominator and to take that guy and move it over to the other side. Does that make sense what I just said? So I'm going to take 13 and multiply it over here. So really what's happening is I'm multiplying the number 13 to both sides. It cancels here and it affects over here. So the first thing I would do is take 13 and I would multiply. I'm left with negative 1 on the right hand side. Did I lose anybody there, or are we cool? Wow, you guys are so talkative. We're cool. All right, so now what do I do? Distribute. Right. So 13y minus 52 equals distribute negative x plus 1. Now it wants me to take everything and make it look just like that. X, y equals number. So what do I do to get x, y equals number? With this. Bring the x over. So I have x plus 13y. And then do what?
Add the 52.
Add the 52 over. Equals 53. And that is standard form. So are they always going to want it in standard form? No. If the question says, find the equation of the normal line, done. Find the equation of the normal line, looking like that, then you have a few extra algebra steps to do. Notice, for this particular problem, this is a calculus problem. The calculus was from here to here. Step to here is the calculus of it. At that point, calculus is done, and what we do now is just algebra. Okay, how do we feel about that? Have I lost anybody, or are we cool? Yay. Okay, so I'm going to teach you one more, well, I got a couple things I want to make sure. Along the same lines of algebra, hold on. Okay. Can I erase this stuff over here? Do we have it all? We're cool? Yes, okay. Okay, so again, we're gonna algebra it as much as we algebra it, and then calculus, and then back to algebra. So this question would say find the gradient, okay? Find the slope. So if I'm looking at this, is there any algebra that I can do to this first? And what is the algebra that I can do? Can I simplify it at all? Can I clean it up? You can bring x to the negative 2 up and multiply it through, yeah, absolutely. So what they're saying is, couldn't I take this guy and multiply it by x to the negative 2? Yes. Or, if you see it like I see it, I say, look, I'm going to take 5x over x squared minus 10 over x squared. I just took the denominator and brought it to both pieces. You're going to get the same answer if you distribute that negative x to the negative 2 through as you would if you simplified this. Like, what would this guy be? It would be 5 over x, right, if I reduced it, and minus 10 over x squared. Are we okay? Over here, you would get 5x. When I multiply, I add to the negative 1. And over here, I would get negative 10x to the negative 2. Well, I just got done saying these two guys are the same thing. Are they indeed the same thing? How can I rewrite this guy? Yeah, I could flip that guy up and make 5x to the negative 1. And then how would I rewrite this thing? 10x to the negative 2. So both of them got me to the same place. I went the long road, that's the short road. Much easier, right? Okay, so now find y prime. I'll give you an opportunity to find y prime. Yesterday I also described y prime as dy dx. Find dy dx. The 5 goes for the ride, x, the negative 1 comes down. When I subtract, I get negative 2. The 10 went for the ride. I bring the negative 2 down and get negative 3. So this is negative 5x to the negative 2, and then plus 20x to the negative 3. That's great. That'd be perfect. Or you could rewrite it as negative 5 over x squared plus 20 over x cubed. How do we feel?
Both ways would work.
Perfect. To me, if I said find the gradient when x is 1, it's easier for me to plug it in here than here-ish, you know, so. All right, are we cool?